This next unit, we're going to talk about polygons. And then even more specific to just being a polygon, we're going to focus on quadrilaterals. And then we're going to get more specific again and talk about parallelograms, rectangles, squares, rhombi, trapezoids, and kites. And so we're just going to get more and more specific as we go. But today we're going to start very general by just talking about polygons in general to get some vocabulary under our belt as we get started. So the first thing that we need to discuss is what is a polygon. So a polygon is a two-dimensional closed figure made up of line segments. So closed means it's a closed shape. You can't pour water in it if you want to kind of look at it like that. And it doesn't overlap. It must have 3 or more sides. That's the only way you can have a closed figure. It has to have the same number of sides as it has angles. And then the sides have to meet at endpoints that are called vertices. Okay, and so if you look at this, this first one is a trapezoid. It's two-dimensional. It is a closed figure as opposed to this Y, which is not a closed figure. It has to have 3 or more sides. It has to have the same number of sides as it has angles, and then the sides have to meet at vertices. And these corners, those are our vertices. And so... and there can't be any overlapping sides. That's where this, there's no overlap. There's where this same number of sides as there are angles is that none of the sides can overlap. And so if you look at these figures, the question is, which one is a polygon? Yes, this trapezoid is a polygon. No, this Y shape is not because it is an open figure. No, this shape is not a polygon because it's not made up of a line segment. This is a curve, and that's not a line segment. Yes, this pentagon is a polygon. This shape is not because it overlaps. It has too many angles and not enough sides. Okay, this one, this octagon is a polygon. This oval is not because it's not made up of line segments. This triangle is. This cube or this prism is not. It's 3-dimensional instead of 2-dimensional, and so yes, it is made up of polygons, but the shape itself is not a polygon. And then this one is not because it overlaps. It has too many angles compared to the number of sides that it has. So then we have 2 kinds of polygons. Once you become a polygon, there are 2 sides. One is called a convex polygon, and one is called a concave polygon. The easiest way that I can remember it is to tell you that a concave caves in. It has this little cave in. And basically what it's creating is it has one interior angle that is more than 180 degrees. So you're looking at these interior angles. That interior angle is about 270 degrees. That interior angle is the same, 270 degrees. So if it has an angle bigger than 180 on the inside, then it is concave. For convex, all the interior angle measures are less than 180 degrees. So each of these interior angle measures, these are interior, each of those interior angle measures is less than 180 degrees. So you can be convex and concave, and remember that concave caves in. So a polygon is equilateral. We've talked about this with a triangle, and the same applies to any generic polygon, not just because a triangle is a polygon, but even more a generic polygon, is all of its sides are the same length. So if all of its sides, it is equilateral. Lateral means sides, equal means equal sides, and we mark that just like we've been marking it all year with these little tick marks on the sides. That means that they're all the same. We don't go by what it looks like, we go by what it's marked or by the information in the problem. A polygon is equiangular, meaning equa, angular meaning angles. Equiangular if all of its angles are the same measure. Okay, so if they are all the same measure, then each of the angles, then it is considered equiangular. All of these are 90 degrees. All of these are 60 degrees. And so that would mean that those figures are equiangular. So what if it's both? What if it's equilateral and equiangular? It is called regular. This is going to be important. We're going to need to know that definition because it's going to affect how we work the problems. So when all of the sides are the same and all of the angles are the same, it is called a regular figure. So notice that you've got this triangle, and it all has the equiangular triangle has 60-degree angles. A square has 90-degree angles. The pentagon has 108-degree angles, hexagon 120, and so on. Now, more specifically, we got a polygon, and then kind of the next row down would be a quadrilateral. So a quadrilateral is any four-sided figure. Quad means four, so a four-sided figure is a quadrilateral. It's a polygon, but that is a quadrilateral. What's important about a quadrilateral that you'll need to remember is that the sum of the interior angles, so all of the angles on the inside, 1, 2, 3, 4, those four angles, add up to be 360 degrees. Now, the reason for this is because if you look at this quadrilateral, if I split this into two triangles, these angles of this triangle on top add up to 180, and these angles down here on this triangle on bottom, they add up to 180. And together, all of those angles make up the four angles of the quadrilateral, which means that they are 360 degrees. Now, so we started with a polygon, and then we went to a quadrilateral, and then from there, we're going to start splitting off, and the way that we're going to split off is by the number of parallel sides. And then we'll further get into what about the angles and what about the sides being congruent and all of that. And so we can classify them by the number of parallel sides. So let's look at some problems involving the sum of the interior angles of a triangle. So if you look at number 1, find the value of x. If all four of these angles are interior, and all four of those angles are supposed to add up to 180, then you would do 110 plus 79 plus 55 plus x is equal to 360. Now, most of you could add those up, subtract from 360, and get that angle x has to be 116 degrees. The sum of the interior angles of a quadrilateral is 360. So we use that same thing here with the algebra, and we can just shortcut this. You don't have to write it all out every step. I would go ahead and combine all your like terms. So we've got all of our x terms that go together. We can combine our like terms and get that. We get 37x, and then combine our plus 7, plus 18, minus 11, and plus 13, and you get plus 27, and those angles all added together should equal 360 degrees. You can go through the algebra and you find out that x is 9. Now, I asked for the measure of angle B. Well, angle B is 8x plus 7. So angle B is 8x plus 7. We now know that x is 9. So we have 72 plus 7, which is 79 degrees. Now this last one, we have one little trick that's thrown in there, because if you notice, this 71 degree angle is exterior. Well, exterior is different from interior, but this is what we know if we go way back to the beginning of geometry. We remember that these two angles, angles that are adjacent, that form a straight line, are supplementary. They are a linear pair. That means that if I take 180 and subtract 71, I find out that this angle is 109. And I need that interior angle because it's the interior angles that add up to 360 for a quadrilateral. Now I'm back to like I did with the second question. Combine your like terms, 10x, 13x, and 8x, and you get 31x. You add 6, negative 2, negative 1, and 109, and you get 112. That equals to the total of 360 degrees for the interior angles. When you go through the math, you get that x is equal to 8. So polygons, you have convex and concave, and what's most important about a polygon is understanding what regular means, because in the future we're going to see problems where it talks about them being regular, and we need to understand what that means and how that's going to affect the problem. More specifically to being a polygon, you have a quadrilateral, and the sum of the angles of the interior angles of a quadrilateral is 360 degrees.